Okay, and welcome back, students that are taking Math for Business and Finance and Math Applications, and we're doing the Chapter 12 Summary Practice Test, and we only have 3 more to go, so I'm going to finish those off in this video. So we're on number 6 here, and it's Lu Ling, owner of Lu's Lube, estimated that he will need $70,000 for new equipment in 7 years. So that's a future value, and that's the time frame. Lu decided to put aside money today so it would be available in the 7 years. Real Bank offers Lu 6%. That's the rate, compounded quarterly, which is 4 times a year. How much must Lu invest to have $70,000 in 7 years? Okay, so we're going to be looking at a future value here. 7 years times 4 compounded quarterly. That's times 4, so that's 28 periods. And 6% divided by 4 is 1.5%. So we jump up to our future value table and we look at the 1.5% for 28 periods. That gives me a factor of 1.5172. So my factor is 1.5172. Oops, sorry. See, I made a mistake. Okay. And that's what I mean by thinking here, because I'm thinking 1.5172. Well, if I have a future value, that means it has to be less than 1. Okay. So I must be using the wrong table, which I am. Okay, I jumped up here to the future value table when I should be using the present value table. Right, so I made a mistake, but because I'm thinking about it, I'm able to catch myself and say, okay, my factor should be 0.6591. Okay, so back down, and like I said, even though I made that mistake, I was able to, oops, come on here, erase that. I was able to catch myself because I know the factor has to be less than 0 going from the future to the present. Okay, so I needed to be looking at the present value table, and I multiply that 0.6591 by the 70,000, and I end up with, let's see here, that's 763, that's 1, 4, 6, $64,137 is how much I need as a present value in order to earn $70,000 in 7 years. Okay. Oh, and by the way, as I did this, notice that I have, why didn't I just do all of the zeros here? Well, notice I have 4 decimal places here. Okay, and 70,000, right, is 1, 2, 3, 4 decimal places. So I know that my decimal is here. I don't need to write in those zeros. Okay, I just know that, and I just need to multiply the 7 times that factor. Okay, that's just that quick shortcut. If you're paying attention and you're thinking, you can save yourself, time and energy on some of these things. Okay, number 7. Bernie Long wants to retire to California when she is 60 years old. Bernie is a man's name. I don't know why, but then again, Bernice, like calling someone Bernie, but then I would call her Bernice Long, not Bernie Long. So when she is 60 years of age. Okay, Bernie is now 40, so the difference between those is 20 years. That's just what's going through my head. She believes that she will need $900,000 to retire comfortably. To date, Bernie has set aside no retirement money, so if she needs $900,000, that's a future value, right? And if Bernie gets 8%, the rate compounded semi-annually, that's times 2, how much must Bernie invest today to meet her $900,000 goal? Okay, so again, this is a present value calculation. We know if you draw the timeline, here's today, and here's the future. okay, and she needs 900,000 then, and she wants to know how much today, and between 40 and 60, that makes this a 20-year period. And if it's compounded semi-annually, that's times 2. So I have 20 years times 2, that's 40 periods. Okay, and my interest rate is 8% divided by the 2 is 4%. Okay, so we have our 4% at 40 years, or 40 periods, and we jump up to our present value table, and we look at the 4% column for 40 periods, and that gives me a factor of 0.2083. So my factor is 0.2083, and I multiply that by the 900,000. Okay, now again, notice, here's what I'm doing. Okay, I know I have 4 decimal places, so 1, 2, 3, 4. I don't need to write down all of those zeros. I start out with a 0 here. Okay, and then I just multiply the 9 times 3 is 27, carry my 2, 72, 74, 18, 187,470 is what she needs today in order to be able to meet her goal of $900,000 20 years from now. Okay. Okay, summary practice test 8, last one. All right, Jim Jones deposited $19,000 in a savings account. Present value at 7%, compounded daily. Okay, at the end of 6 years, what is the balance in Jim's account? Okay, so this is the first time that we're doing a problem with the compounded daily, and if we jump up to the interest on a dollar compounded daily chart, okay, we see that we have 7% and for 6 years, and our factor is 1.5219. So we take the 1.5219 and multiply it by the 19,000, and we end up with $28,916.10. Okay, that's what he'll have in his account at the end of 6 years. Okay, so with that said, we're done with the summary practice test. And as you can see, if you've done all of this work, like I've just done through all of the drill problems and the word problems and this practice test, that it's basically doing the same thing again and again and again. It's the same pattern with just the little idiosyncrasies, how many compounding periods that you have, whether you're looking for future value or present value. If a factor changes, if one of the variables change, you look at a lump, you figure out the lump sum at a particular point in time, and then treat that as a beginning balance as the different variables change. Okay, so really it's basically all the same thing, but just learning how to do the, paying attention to those idiosyncrasies. So with that said, good luck to you, and I will see you all for chapter 13.